There's nothing like a challenging problem. Of course, these types of problems are no exception. Let's consider two curves. We've got f of x equals 3x cubed minus x squared minus 10x, and g of x equals 2x minus x squared. Well, if we wanted to find the area between these two curves, of course, we'd have to figure out which one is greater and which one's less. Now, for our purposes, that means that the first thing we should do is find the points where these two curves intersect one another. So, of course, we set f of x equal to g of x and figure that out. And we, of course, in this case, have 3x cubed minus x squared minus 10x set equal to 2x minus x squared. To do that, I'm going to add my x squared term to the other side, subtract my 2x to the other side to get 3x cubed minus 12x, and we might recognize that that means that 3x is a common factor, and so let's factor that out. We're going to get 3x times x squared minus 4, setting each factor equal to 0. Of course, that gives us x equals 0 as one of those points of intersection. Of course, if x squared minus 4 is equal to 0, that means we get two more zeros at x equals positive or negative 2. So in fact, we have 3 points of intersection. Well, 3 points of intersection might indicate that one of these curves is going to be higher than the other at different points. In other words, it won't be the case that f of x is always greater than or equal to g of x. So what do we do? Well, this would be a case where we would go through and we would use our graphing techniques. That's the subject of another topic covered in my videos. So let's go ahead and take the graphs as having been read already. Here they are. I've got my curve f of x. It's a cubic curve. You can see f of x here in red, and so I'll write f of x up here. And of course, g of x in blue is sometimes above and sometimes below. We need to figure that out. Well, on the interval from negative 2, which is our first point of intersection, to 0, which is our next point of intersection, f is greater than g. So f is greater than g in this case, greater than or equal to at least. And then from 0 to positive 2, we can see that g is greater than f. So that means that if we're going to set up our integral to take the summation right here, we're going to have to do this as a sum of two different integrals. We're going to go from negative 2 to 0 of first f of x minus g of x. So we're going to take 3x cubed minus x squared minus 10x minus 2x minus x squared dx. And we're going to add to that our integral that goes from 0 to 2 of g of x minus f of x. So we would have 2x minus x squared minus quantity 3x cubed minus x squared minus 10x dx. I'm not going to integrate it in this form. Of course, I like it when I can simplify my expressions. The simpler the better. I'm just that kind of guy. So I'm going to go ahead and I'm going to simplify these. So that's going to be 3x cubed minus 12x dx plus, on the interval from negative 2 to 0, and 12x minus 3x cubed dx on the interval from 0 to 2. Well, that's useful for us because now the integral actually should be very familiar. The only difference is the signs. Of course, not everything's going to be dropping out, right? Remember, we're going on two different intervals, so we're going to have to evaluate this a couple of times. But taking our integral is going to give us 3/4 of x to the fourth minus 6 times x squared, right? Remember, we're dividing by 2. And so that's going to be evaluated from negative 2 to 0. And we're going to be adding to that the quantity that we're going to get if we evaluate 6x squared minus 3/4 of x to the fourth on the interval from 0 to 2. Okay, so this is a matter of making a couple of substitutions in here. And I'll note that whenever we put in 0 in both of these terms, we're just going to get 0. So it's going to boil down to what happens with these negative 2's and 2. So let's see what happens right here. In this case, I'm going to start at 0, and I'm going to subtract away 3/4 of 2 to the 4th. Actually, negative 2 to the 4th. I need to be careful right there. Negative 2 to the 4th. There we go. Minus 6 times negative 2 squared. And I'm going to be adding to that quantity that I get right here. Remember, it's 0 minus this quantity here, so we do have to be careful with subtraction signs, right? That's a very big deal. Plus the quantity that we're going to get if we substitute in 2. So 6 times 2 squared minus 3/4 of 2 to the 4th. And all of that is going to be minus 0 in this case. So simplifying a little bit. So that's going to be 3/4 of negative 2 to the 4th. Well, negative 2 to the 4th is 16. 16 divided by 4 is 4. Times 3, that's 12. So we're going to take negative 12, distribute the negative sign to both terms. We've got plus 24. Plus 24 minus 12. A little bit of simplification shows that 24 plus 24 minus 12 times 12 is basically the same thing as 24. And so 24 is the total area between these two curves.